Okay, so we've looked at Pythagoras and trigonometry, and this week we're really learning to apply these in different situations. So let's have a look at number one. Dave is 1.7 metres tall. There's Dave. He looks up with an angle of elevation. Now, an angle of elevation will be this angle here. It's the angle against the horizontal, up for elevation, down for an angle of depression. He's looking at the top of a tree. There's our tree. And if Dave is 22 metres away from the base of the tree, and he's 1.7 metres tall, it's asking us how tall the tree is. So we want to know the height of the tree here, the height. Now that's not a triangle at the moment, it's a trapezium, but I'm just going to cut the triangle here, and I end up with 24 degrees and 22 metres. And then my height actually only goes up to this bit where my triangle is. So let's find our height. Well, we're using opposite and adjacent. O and A is TOA, so I use tan theta equals O over A. I substitute. Tan 24 equals H divided by 22. I rearrange. 22 times tan 24 must be whatever H is. So that's H from there to there. Now looking back at my diagram, if H is from there to there, this distance is Dave's height, which is 1.7. So therefore I'm going to do, I'll type it all in one go. So tan 24 multiplied by 22 gives us that H bit, plus Dave's height of 1.7. There we go. So the tree is 11.5 metres tall to 2 decimal places because the 5 rounds it up. Number 2. Find the area of the following trapezium. Well, to find the area of a trapezium, it's A plus B multiplied by H divided by 2. We don't have A, so we need to find this distance from there to there. So I'm going to split this down here to make a triangle here. Now we need to find this little length on the bottom, because if I know the distance from there to there, I can take it away from 15 to find what A is. Now for this triangle, I know that that's 10, I know that that's 14, but we don't know what X is, so we're going to use Pythagoras, that's C. So C squared is obviously A squared plus B squared, and if I just want to find out what this A is, A squared equals C squared minus B squared, or however you want to rearrange this. Let's substitute. X squared equals 14 squared minus 10 squared. Type that into a calculator, 96. Yep, so X squared is 96, so the square root of 96 gives us our X equals 9.798. So that's the distance from there to there. Now if I do 15 take away that, I have my A, which is 5.2 centimetres. So I needed to find the 5.2, and I'll find that because A equals 15 minus whatever that is. So I did all of this Pythagoras just to find A. Now the area of a trapezium is A plus B multiplied by the height divided by 2. Let's substitute. 5 plus 2 plus the 15 times 10 divided by 2. So what we did, A and B, the height of our trapezium is 10, type that into a calculator, so 5.2 plus 15 multiplied by 10 divided by 2. The area of our trapezium is 101 squared centimetres. Question 3. I'll sort of focus that for you here. Right, what angle does the diagonal line BF make with the base BH? Okay, so it's asking for this angle here. So I'm going to draw out this triangle. Basically, that diagonal is BF, and the bottom one's BH, and that's the angle it's trying to work out. So you can see I've just drawn this triangle over here. I know the height of the triangle is 9. Alright, so that's good. I just need to either find BH or BF. If I find one of them, then I can use trigonometry to find the angle. So I'm going to find BH, because if this is 12, that will be the same as that one, which is 7. So I'm going to use Pythagoras to find the hypotenuse of the bottom of the base. So for the base, I've got a squared plus b squared equals c squared. So c squared must be 7 squared plus 12 squared. We'll type that into a calculator, which is 193. So c must be the square root of 193. Now you can see I've left that, I'll move this down for you. So I did Pythagoras here. That squared plus that squared must equal that squared, which is now the base of my triangle. Now I've left it as a square root, because then when I use my trigonometry it should work. So trigonometry now, opposite and adjacent, because that's the hypotenuse, which is tan. So tan of my angle is O divided by A. Let's substitute. So tan of my angle is opposite, 9, adjacent, square root 193. So to find my angle, it's inverse tan 9 over the square root of 193, which we can just type in one go. So I'm going to go square root of 193, 9 divided by that, so I've got the brackets, and I'm going to go second function tan of that answer. I'll show you there. And there it is. So the angle is 32.94 degrees to 2 decimal places. So these are the 3 questions, which is about Pythagoras and trigonometry and applying them.